Hello my dear students, welcome back to my class Easy Maths by Sukumar. This is Sukumar, mathematics teacher. See my dear students, in the last class we discussed about remainder theorem. What is remainder theorem? If p of x is a polynomial divided by x minus a linear polynomial, then the remainder is p of a. If p of x is a polynomial, it is divided by x minus a, then the remainder is P of A. P of A is the remainder. See, this remainder theorem helps us to find the remainder without actual division. But coming to this theorem, factor theorem, if P of x is a polynomial of degree that is greater than or equal to 1, that means it's a positive integer and A is any real number. A is any real number, then x minus is a factor of P of x. See, this x minus is a factor of p of x means if p of a is equal to 0. As I told you, p of a is the remainder according to the remainder theorem. If this p of a is equal to 0 means, then what? This x minus is a factor. See, in our daily calculations, 24 divided by 3 is equal to 8. That means this 3 is the factor of 24. Why? This 24 is exactly divisible by 3. This 24 is exactly divisible by 3. How many times? 3 times. So this 3 is called the factor. Why? We get the remainder here 0. Like that, if this p of x is divided by x minus a, then the remainder is 0. This remainder is 0. So that means the value of the polynomial is 0. That means this x minus e is called the factor of p of x. See, for example, I can take one example, x square plus 2x plus 1. This is a polynomial. If it is divided by x plus 1, then the remainder is 0. Remainder is 0. That means this p of minus 1, is equal to 0. Why? This polynomial is divided by x plus 1, so p of minus 1 is equal to 0. This is called remainder. If the remainder is 0, then x plus 1 is a factor here in this case. Okay. See my dear students, I hope you understand this factor theorem. If p of x is a polynomial of degree n is greater than or equal to 1 and a is any real number, then x minus 1 is a factor of p of x. That means that p of a is equal to 0. That means that remainder is equal to 0. That means x minus a is a factor. This converse is also true. Converse means what? What is converse? Then part will become if part will become then part, like that. So here, if x minus is a factor means factor of polynomial p of x means then p of a is equal to 0. Converse is also true. Right. See, what is the division algorithm actually? P of x, that means dividend is equal to q of x into g of x plus r of x, where this is remainder, this is what? A divisor, quotient, and this is dividend. So according to the remainder theorem, here how do you write this? P of x is equal to, here this x minus a is a what? The divisor. When this x minus a is a divisor, p of x is dividend. So here you write x minus a. So what is r of x here? This is p of a. Okay, p of a is the remainder. This x minus a is a divisor. When this polynomial is divided by x minus a, we will get here what? Remainder p of a. So here, this remainder is 0. This remainder is 0. P of x is equal to q of x into x minus a plus 0. So here q of x into x minus a. This p of x has no remainder, that is 0 remainder. Therefore, here this p of x can be written as q of x times x minus a. That means this x minus a is a factor of P of X. X minus is a factor of Q of X. I have given example now. 24 is equal to 8 times 3 plus 0. Here the remainder is 0. So this 3 is called the factor of 24. This 3 is called the factor of 24. Right. Why? The remainder is 0. This is remainder theorem. Here the converse is also true. What is the converse? Converse means what? Converse means if part will become then part will become if part. For example, if you study well, then you will be passed. If I passed means then I was studied well, like that. That is converse. So here, my dear students, converse is true here. X minus is a factor means here this P of X, factor of P of X means that P of A is equal to 0. So P of A is equal to 0, right? So this is about factor theorem, right? In the next exercise, exercise 2.4, what is the first question? Determine which of the following polynomials has x plus 1 as a factor. Has x plus 1 as a factor, right? Exercise 2.4, first question, first set. Determine which of the following polynomials. Which of the following polynomials has x plus 1? Has x plus 1 as a factor. X plus 1 as a factor. The number 1, x cube minus x square minus x plus 1. And I will write one more, fourth question also. X cube minus x square minus 3 minus root 3x plus root 3. This is, I have taken first and last one, right? Look here, students. Determine which of the following polynomial has x plus 1 as a factor. So here x plus 1 as a factor means we have to verify here. That means first this polynomial, let this polynomial P of X is equal to x cube minus x square minus x plus 1. As I told you, according to the factor theorem, this x plus 1 factor means this P of minus 1 is the remainder. If the remainder is 0, that P of minus 1 is 0, then we can say this x plus 1 is a factor of this given polynomial. I hope you understand this concept, right? So this is implies P of minus 1 is equal to minus 1 whole cube minus 1 whole square minus of minus 1 plus 1. So this is equal to minus 1 whole square is plus 1. So here plus into minus is minus 1. This is plus 1 plus 1. So all get cancelled. This is 0. Therefore, what can you say about this? Here the remainder is 0. That means P of minus 1 is equal to 0. Therefore, x plus 1 is a factor. X plus 1 is a factor of P of X. Similarly, here also, my dear students, let the given polynomial P of X is equal to x cube minus x square minus of 3 minus root 3x plus root 3. Here x plus 1 is a factor. To verify that x plus 1 is a factor means take P of minus 1. Substitute x is equal to minus 1 here. That means minus 1 whole cube minus of minus 1 whole square minus of 3 minus root 3 into minus 1 plus root 3. So this is minus 1 whole cube is minus 1 minus of minus 1 whole square is plus 1. Minus 1 whole square is plus 1. Let us multiply with minus now. Minus into minus plus, that is 3 minus root 3. This minus into minus is plus. Plus of 3 minus root 3. Right. Plus root 3. Look here, my dear students. Here this plus root 3 minus root 3 get cancelled, and here minus 2 plus 3, this is equal to plus 1. Minus 2 plus 3 is plus 1. So here this p of minus 1 is equal to plus 1. Is it equal to 0? It is not equal to 0. If this p of minus 1 is equal to 0, then x plus 1 is a factor. Therefore here this x plus 1 is not a factor. This x plus 1 is not a factor of p of x. This x plus 1 is not a factor of p of x. I hope you understand. I want to tell you one more thing, students, here. Note. With note here. 2 x plus 1 is a factor. Just remember, my dear students, 2x plus 1 a factor of p of x, just remember the sum of coefficients of odd powers of x should be equal to the sum of coefficients of even powers of x. Okay, the sum of coefficients of odd powers of x equal to sum of coefficients of even powers of x, then this x plus 1 is a factor of p of x. Okay, just this is additional information. Right, here take the odd powers and even powers. Here these are odd powers. X cube minus x, that means here power 1 will be there. So what are their coefficients here? 1 minus 1. What about 1 minus 1? 0. Coming to the even powers, minus x square and this x power 0. This is also considered as even. That means here minus 1 plus 1. So this is also 0. That means here sum of the coefficients of odd powers of x and sum of coefficients of even powers of both are equal. Therefore, what is the conclusion? X plus 1 is a factor. Coming to this fourth question here, odd powers of x. What are the odd powers here? 1 and here 3 minus, coefficients of odd powers of x, that is 1. So this is minus of 3 minus root 3. This is plus 1, but the coefficient of x, another odd power of x, that coefficient is 3 minus root 3, minus of 3 minus root 3. So here let us do 1 minus 3 plus root 3. This is minus 2 plus root 3. This is minus 2 plus root 3. Coming to the even powers here, this is minus 1. Even powers means minus x square and root 3. So this is minus 1 plus root 3. So here these are not equal now, my dear students. Coefficients of odd powers of x and coefficients of even powers of x, they are not equal. If they are equal, then x plus 1 is a factor, right? Second set, use the factor theorem to determine whether g of x is a factor of f of x. The first question, f of x is equal to 5x cube plus x square minus 5x minus 1, comma g of x is equal to x plus 1. So we have to verify that here this g of x is a factor of f of x or not. So according to the remainder theorem, factor theorem, here this g of x is the factor of this f of x, means here this f of minus 1, that means here x plus 1 0, so x is equal to minus 1. That means this f of minus 1 should be equal to 0. This f of minus 1 is equal to 0, right? So actually this f of minus 1 is called factor according to the, this f of minus 1 is called remainder, right, according to the remainder theorem. So let us verify now, this f of minus 1 is equal to 0 or not, right? So 5 times minus 1 whole cube plus minus 1 whole square minus 5 times minus 1 minus 1. So this is 5 times minus 1 whole cube is minus 1 plus minus 1 whole square is plus 1. So minus into minus, this is plus 5, this is minus 1. So here minus 5 plus 1 plus 5 minus 1. Minus 5 into minus 1 minus 5. So here plus 5 minus 5 plus 1 minus 1 cancel. This is 0. So here f of minus 1 is equal to 0. That means this x plus 1 is a factor. Therefore, this x plus 1 is a factor of f of x. X plus 1 means what? This g of x is a factor of f of x. Coming to the, here there are 5 questions. 1, 2, 3, 4, 5. I will teach you that 5th question now. Right. 5th question. 5th bit in second set. F of x is equal to 4x cube plus 20x square plus 33x plus 18 comma g of x is equal to 2x plus 3. Right. Look here, my dear students. This g of x is a factor of this f of x, means this f of what? 2x plus 3 is 0. 2x is equal to minus 3. That means x is equal to minus 3 by 2. So this f of minus 3 by 2 value should be equal to 0. Then that means that is the remainder. So then this 2x plus 3 is called the factor. 2x plus 3 is the factor of this f of x. Let us verify now. 4 times minus 3 by 2 whole cube plus 20 times minus 3 by 2 whole square plus 33 times minus 3 by 2 plus 18. 4 times minus 3 by 2 whole cube plus 20 times minus 3 by 2 whole square plus 33 times minus 3 by 2 plus 18. Okay. So 4 times minus 3 by 2 whole cube means, my dear students, minus 3 into minus 3 into minus 3 by 2 into 2 into 2. 3 3s are 9, 9 3s are 27. Minus 27 by 8. Why you get minus here? Minus into minus plus, plus into minus minus. So that is minus 27 by 8 plus 20 into, this is minus 3 by 2 whole square is 9 by 4. Minus 3 whole square is 9, 2 square is 4. Plus into minus minus 33 into 3 by 2 plus 18. Okay. Now here 4 in 8 2 times, here 4 in 25 times. That means minus 27 by 2 plus 5 9s are 45. Here 33 3s are 99 by 2 plus 18. Students, I take minus 27 by 2 minus 99 by 2. So minus 27 by 2 minus 99 by 2 plus 45 plus 18 is plus 63. Okay. So this minus 27 minus 99 both are like fractions. So this is minus 126 by 3 plus 63. So minus 126 by 2 plus 63. So this here 63 times. So minus 63 plus 63, this is equal to 0. So that remainder value is 0. That means f of minus 3 by 2 is equal to 0. Therefore, what is the factor? Here this 2x plus 3 is a factor of f of x. Coming to the third bit in exercise 2.4. Exercise 2.4. Let me read out the sum. Show that x minus 2, x plus 3, x minus 4 are factors of x cube minus 3x square minus 10x plus 24. Right. So we have to show that. That means these three are the factors. Okay. X minus 2 is a factor means solution. X minus 2 is a factor means, my dear students, this p of x cube minus 3x square minus 10x plus 24. That means p of 2 should be equal to 0. We have to verify that p of 2, whether p of 2 is equal to 0 or not. So that means 2 cube minus 3 into 2 square minus 10 into 2 plus 24. 2 cube is 8, 2 square is 4, 4 into 3 is 12 minus 20 plus 24. x cube minus 3x square minus 10x, is it right? plus 24, right? So x minus 2, 2 cube minus 3 into 2 square minus 10 into 2, 2 plus 24. 2 cube is 8, 4 3s are 12, 10 2s are 20. Okay, look, 8 minus 12 is minus 4 minus 20 plus 24. So this is minus 24 plus 24. This is equal to 0. That means P of 2 is equal to 0. Therefore, what is the factor? X minus 2 is a factor. Right, coming to this x plus 3. X plus 3 is a factor means, my dear students, this P of minus 3 should be equal to 0. Let us verify now. Substitute minus 3 in the given polynomial. That means minus 3 whole cube minus 3 into minus 3 whole square, minus 3 whole cube minus 3 into minus 3 whole square minus 10 into minus 3 plus 24. Okay, see here, this is minus 27 minus 3 whole square means 9. 9 into 3 minus 27 minus into minus plus 30 plus 24. Here this is minus 54 plus 54. Both get cancelled. This is 0. That means x plus 3 is a factor. Here this x plus 3 is a factor. This P of minus 3 is equal to 0. That means x plus 3 is a factor. I am apology for the lighting. Just know the power has gone. Okay. Right. Next one is x minus 4 is a factor, my dear students. X minus 4 is factor means Factor means what? This P of 4. P of 4 means what? 4 cube minus 3 into 4 square minus 10 into 4 plus 24. 4 cube minus 3 into 4 square minus 10 into 4 plus 24. 4 cube means what? 4 4s are 16, 16 4s are 64 minus 4 square is what? 4 square means 16 plus 10 4s are 40 plus 24. So this is 64. 3 16s are 48 minus 40 plus 24. Okay, let us do now. 64 plus 24 is what? That is 88. This is also 88. 88 minus 88, 0. So this P of 4 is equal to 0. My dear students, are you here? P of 4 is equal to 0. That means that x minus 4 is equal to, x minus 4 is a factor. See here, x minus 2 is a factor. Why? That P of 2 is equal to 0. Here x plus 3 is a factor. That means P of minus 3 is equal to 0. Here x minus 4 is also factor. Why? That P of 4 is equal to 0. So according to the factor theorem, this x minus 2, x plus 3 and x minus 4 all are the factors. Fifth question in exercise 2.4. If both x minus 2 and x minus 1 by 2 are factors of px square plus 5x plus r, show that p is equal to r. See, let the given polynomial take p of x is equal to px square, not p of x, some f of x, plus 5x plus r. Okay, so here, my dear students, this x minus 2 is a factor. X minus 2 is a factor here. X minus 1 by 2 is a factor. That means that f of 2 should be equal to 0. Here f of 1 by 2 should be equal to 0. This f of 2 is equal to 0. Here f of 1 by 2 is equal to 0. Let us substitute x is equal to 2 in the given polynomial. In this polynomial, right, f of 2 means p into 2 square plus 5 into 2 plus r. This is equal to 0. This is implies 4p plus 10 plus r is equal to 0. This is implies 4p plus r is equal to minus 10. This is equation 1. Now substitute x is equal to 1 by 2 here. That means p into 1 by 2 whole square plus 5 into 1 by 2 plus r. So this is equal to 0. So this is implies P times 1 by 4 plus 5 by 2 plus R. This is equal to 0. So this is implies, look, here the LCM is what? 4 is the LCM. 4 is the LCM. That means P plus 4 by 2 is 2. 2 times 5 is 10 plus 4R. This is equal to 0. So this is implies P plus 4R plus 10 is equal to 0. 4 times 0 is 0. So here P plus 4R is equal to minus 10. This is equation 2. This is f of 1 by 2. Now from 1 and 2, from equation 1 and equation 2, equation 1 is 4P plus R is equal to 0. Equation 2, P plus 4R is equal to 0. 4P plus R is equal to minus 10. Here P plus 4R is equal to minus 10. Both equations are equal, no? They are equal to minus 10. Here also minus 10. That means this 4P plus R should be equal to P plus 4R. Now collect the like terms here. That means 4P minus P is equal to 4R minus R. So this 3P is equal to 3R. Cancel the 3 on both sides. That means P is equal to R. P is equal to R. Please write down.